Okay, right. So the objective of what we're going to be doing today is learning how to use software and integrate it with our documents. So I'm sure all of us have been through the process where we're writing a Word document or a Google Doc and we've generated a figure and then we copy and paste it in. But then the margins all change and you have to like drag it around or reformat the thing. And then suddenly you like write another 3 paragraphs and then you have to like drag it around to reformat the thing again. Or like, surprise, one of your males was actually a female, so you can't use that data point anymore, so you have to take it out of the graph and remake the figure and then repaste it into the, and it gets really annoying that you have to do that over and over again for all of your different graphs. So R Markdown is a solution to that, where we can put our code in line with our document. And so this is really nice both for publication quality things like manuscripts or even your dissertation. There was a person on campus, Ryan Peak, who wrote a package called Aggie Down, which is an R Markdown. It's written around R Markdown to format your dissertation to UC Davis standards. So if you want to use that, we can talk about that later. Actually, I've never used it, so you can talk to Louise later. I'm sure I could also talk about it if I looked at it, but I haven't looked at it yet. Or it's also just really nice to say, like, when you're talking to your advisor, you've made a group of figures, you want to write some text and explain what you did, so you write something up quickly and you send that along. And it packages together both the thoughts that you're thinking or the methods that you used with the figures that you've created. So we are going to work through doing some of those today. So to get started, if everybody can open RStudio, that would be great. Can everybody see my screen the way I have it laid out right now? And the font's big enough? Okay, great. So typically when you first launch R, hang on, I'm gonna turn this off. When you first launch R and RStudio, RStudio wraps around R. So you come down here in the console and you see R giving you a message about what version you're using, that there's no warranty and it's free and collaborative and all of those sorts of things. And then the rest of this is RStudio that is built around R. So we have our script up top. This is like our work area. Any objects that we have for the global environment get sent over here. So things that we create while we're programming. Anything that we run gets sent down and actually run in the console, and output is printed out down there. And then we have this helpful little pane down here where our files, plots, packages, help, and viewer all are. So any file that is in our directory that we've clicked on. So for instance, if I go back up one level, I can see a bunch of my project directories. So this is what you can see on your system, and you can also create new folders from here by clicking on this button. Plots that you make appear down here. Packages that you've installed, you can see what packages they are and what version, and they have a little checkbox if you've loaded them with the library function. Help, and then viewer also allows you to view things that you create. So the reason that I'm going through this is because we're actually going to create a new folder. I made one in my projects folder called 2020-0122_R Markdown. And the reason that we're doing this is because unlike an R script, an R Markdown file interacts with a lot of the things in its working directory. So wherever your R Markdown lives, when you execute it, that becomes that that document's working directory, and it will output all of the files and folders and those sorts of things associated with it into that directory. So that's similar to if you're using an R script and you give it a path to your data file. But instead of just reading things in, it's also outputting a bunch of documents as well. So if you can, you don't have to do this, but to stay organized, I like to put things into their own folder. So for me, it made sense for it to live in a projects directory that I already had, and then I named it 2020-01-2022 R Markdown, and that's where I'm going to be saving all of our files for today. So you can do that by using the new folder button, or you can create it on your desktop. Okay. So that's a little bit of organization. But now we are actually going to create our R Markdown file. So when we first opened RStudio, it actually opened an R script. So that's what this is here, this untitled one. But if we wanted an R Markdown file, what we would do is come to File. This is really small, I'm sorry. And then the first one there says New File. And then we can come over here and do R Markdown. So if I click on this, a new dialog box appears. And I can pick what I want to create, what type of document I want to generate using R Markdown. So there's a lot of different options. You can create a document, a presentation, an R Shiny app, or do something else from a template. The two most common ones that I use are document and presentation, and I definitely use document the most. And then you can also pick if you want it to be an HTML, a PDF, or a Word document upon knitting. HTML is a good default because you don't need other software installed in order to generate this file, but you can always switch this option later. And then this title and the author don't actually get put into like the file name where you save it. They get put into a header on the file, so they're included as part of the document. So I always make that mistake, and then I'll say something like 2020 0122 R Markdown as the name, and then that becomes the title of my document, and that's not really what I want. So instead, I would want it to be something like tutorial on how to use R Markdown. And once I have a title that I'm satisfied with, again, this can change later, and the author's filled out, I click OK, and then a new document appears. And we see that this is the information that we included in that dialog box. So it's separated by 3 dashes, or framed by 3 dashes, so one on the first line and one on the line 6. And then we have the information that we gave it, so the title, and then a colon, and then the title that we gave it, author, colon, my name, date, colon, the date, and then output. You don't actually need all of this here. You can delete it, and the only thing that you really need is to have output specifying what type of document you want to output. But sometimes it's nice to specify things like title and author, so I'm going to leave it there for now. So that's what's called a YAML header. It's called YAML because it's yet another Markdown language is what that specifies. And the idea is that YAML is easier to read than a lot of other Markdown languages or computer formatted text. So that's sort of why that was born. Okay, so that's this first part that appeared, but we also have a lot of other stuff that came up in this default R Markdown document. So whenever you generate an R Markdown document, what happens is this sort of template pops up. And it's really useful because it's sort of a reminder of how R Markdown works. So the first thing that we encounter is this box, basically. And it's 3 backticks. So those are not quotes, they're backticks, which is a key that on my computer is underneath the tilde, just underneath the escape in the top left-hand corner. And then a curly bracket. And then I specify which language this code is in. It's running in R. I give it a name. And then I give it some other parameters. So this is what's called a code box. So unlike in an R script where you can write your code and then that's what generates and what you run, you put your code into these code boxes in R Markdown. Anything outside of the code box and outside of this YAML header is plain text. So this is like the text that you would write in your Word document describing your write-up or analysis or your findings or the figure that you're generating. And we'll go over what this does in a little bit, but a teaser is that it sets global options for your Markdown file. Okay, so that's a code chunk. And then the rest that we see is plain text. So this is an R Markdown document. Markdown is a simple formatting syntax, authoring HTML, PDF, and those sorts of things. I want to go over what Markdown itself looks like because it's different. It's a little, it takes some getting used to. But basically, Markdown was born out of the fact that HTML is annoying to read and write, but Markdown is less annoying to read and write and then can get parsed into HTML to build web pages and those sorts of things later. So the website that I'm on here is called hackmd.io. It's like Google Docs, but the reason that I like it is because you write in Markdown and then on the other side of the screen, the formatted Markdown appears. So it's nice for teaching and showing people what Markdown looks like. So some formatting that you can do. If you put a single hashtag or any number of hashtags, that specifies a header. So if I do one hashtag, that's like my major header, the title of the document. If I put 2 hashtags, this is like a subtitle. And then 3 is a super subtitle. Thank you, Louise. It's collaborative. So Louise copied the URL and now he's editing it too. And he's doing another subtitle. So you get the point with the hashtags. You can use as many as you want to get different levels of headers delineating sections in your document. Some other formatting that's useful, if you want to type in bold, you frame your text in 2 asterisks. And if you want to type in italics, you frame it in 1 asterisk. And when you're working with clever parsers, I guess, like GitHub or R Markdown or HackMD, they are really nice to you. And when you forget whether bold is 1 or 2 asterisks and get it confused with italics, it gives you a cheat sheet and tells you which is which by automatically italicizing the thing in between before it renders it over here, which is nice. So RStudio will do that as well. I think there's even strike through too. Nope. You can do strike through some other way. Haha. Strike through. Okay. If you want to insert a figure, you can do that with an exclamation point, double brackets, and then the path to the figure. I did not prepare a path on, I think, can you use a URL? So usually this would be like a path on your desktop or something, but in our case, copy link, copy link, copy link, copy link location. There we go. Okay. Whoa. Okay. Path to figure. Let's see. Let's change it out for a URL. Did that work? Nope. I'd have to find a valid URL, but you see how a little box appeared here for the figure? Theoretically, a figure would appear. So if this was a document, like a PNG on your desktop or something, and you gave the path to that PNG, it would then appear here, which is what we can practice with in R in a little bit. You can also make tables, which is what all of this text looks like, and it ends up formatting nicely for you. If you're working in R, these get built automatically for you, which is nice. And then what's something else? Oh, a link. Let's say that you want to link to something. You would say, I'm putting a link here, and then you would put the website here. So let's say we wanted to link to Gmail, and now this is hyperlinked, and if you clicked on it, you would go to gmail.com. So this is how Markdown text works, and then any other text, any other text that you write just appears. Yes, Shannon. Oh, bullet points, yes. There are multiple options for bullet points. You can use this syntax with a plus sign, or you can use dashes. I don't think there's another. Oh, is there asterisk? And then if you want numbers, you can do I skipped 2, whoops. But actually it's weird because you can also do, in not HackMD, which is smart, you could also just list numbers and they would auto solve to the correct sequence of numbers. 1, 1, 1, 1, yeah. Oh, so yeah, to get header links that jump later into the document, you can put in a table of contents. So that's TOC separated in brackets. And now we have our headers where we could jump to that header or jump to our subtitle or to our super subtitle. So if this was a real document, that would look nicer. And you can put the table of contents anywhere under any header and it will solve correctly. We will test it later today. I am under the impression that it does, but I actually have no idea. It might be a HackMD thing, and if that's the case, we will Google how to do it in our Markdown, and there will be a solution. More questions about the Markdown syntax? Okay, yeah, so if this was a nicely formatted document, it actually does look nice in Markdown as well, not just formatted, which is a lot nicer than interacting with HTML. So that's that. Yes, Hannah? Let's do it in R where we'll create an image on our computer and then do that together. But HackMD is special in that you can usually use a URL and then the image gets put into your document. But once something's rendered, the image is packaged inside of it. So you just need to give somebody the document. You don't need to give them the file that like you use to generate the document, if that makes sense. Yeah, okay. Other questions? Okay, great. So that's the syntax that we use around our code blocks in R Markdown. Okay. So why don't we, I'm going to delete all of the code chunks here. And I'm just going to knit this. So there's a chance that this might not work for some people. Well, first let's save the document because you have to save something to be able to knit it. So if I'm going to put it into that lovely little projects folder that I had created. Where is it? There it is. And I'm going to name it Markdown tutorial, although it doesn't really matter what you name yours. And then I see that it appears over here as Markdown tutorial, so it exists now as an RMD, which stands for R Markdown. And then I'm going to click knit. And when I click knit, it automatically saves my document if I've already saved it in the past. And then what happens is over here in my file pane, I see that there's now a markdown_tutorial.html that was created. And I think the automatic configuration is that this HTML pops up after you knit it. You might have disabled that on your system, which we can come around and fix later. And if you did, you can double click on it and it should open it in your default browser. So tutorial on how to use R Markdown, we see that our YAML header was rendered. And then our R Markdown header came up, and then our text appeared. And it knitted really quickly because it only had to convert the text that we had written into this Markdown language and then put it into an HTML. When you have a lot of code, sometimes it takes a little bit longer to run. Questions about that? Did it not work for anybody? It requires some packages, which I think if you installed tidyverse ever, I think come with tidyverse. Okay. Great. So let's now write a little bit of code. So to generate a code block, I have a couple options. I can do insert, and then we see another cool feature. So R is the default, and if I click that, then an R code chunk is inserted. So it types the 6 backticks that we need for us, the curly brackets, and then R, which is the software engine that is running that code chunk. But I could also run all sorts of other types of code as well. So if you have these installed on your system and they're in your path, then you can run them. So for example, let's say I wanted to run some bash code. So I insert a bash chunk, and then the engine, instead of saying R, now switches to bash. So that's one nice thing about these documents as well, is that it's one of the few ways that you can integrate multiple languages all into one document, which is really nice when you're communicating your workflows, especially if the bash code that you chose to run doesn't take 7 hours and only takes like 5 minutes or something like that. But even just for communication, like for yourself in the future, if you want to document a workflow that did take a long time to run but used multiple languages, you can do it in R, which is nice using R Markdown. Okay, I'm going to delete our bash code chunk because I don't actually want it. And let's do, I like the iris data set. So let's use iris, and I am going to type head of iris. Yeah, of course. So Iris is a built-in data set that comes with R. And by using the head function, the first 6 rows are going to appear. So if I click knit, it's going to automatically save our document. And then the HTML is going to pop up. And then we see 2 things have now been included. First, we have our code chunk, which shows us the code that we ran. And then we have the output of that code chunk here, the first 6 lines of this Iris data set. Okay, so I'm going to copy this and then paste it below. And now this time I want to plot Iris, and I'm going to do Iris sepal length by Iris sepal width. And then I'm going to click knit again. And now we see that because these are separate code chunks, we get the output of both of them, and they're separated by their outputs. And we have a graph now that we created using our code where sepal width is plotted against sepal length. Okay, so that's very nice. But now that we have multiple code chunks, there's some things that we can use to keep track of our document that are built in R. So if I click this button down here, we see that RStudio has organized our document for us. So we have a tutorial on how to use R Markdown. That's the title of our document. It tells us that we have a chunk that's named setup. And then under R Markdown, we have chunk 2 and chunk 3. We can name these chunks. So the way that we do that is we put a space after R, and then we would name it something. So I'm going to name this one head Iris. And then I'm going to put a space after this one and name it plot Iris. And now if I come down here and click on this again, our code chunks are now named. The other thing that will happen, I'm going to make an intentional error here. I'm going to delete the TH, and it's just going to say sepal width. And then I'm going to click knit. That shouldn't have worked. What?
R will automatically assume that, like, if you stop typing, it'll then there's an option.
Does it really?
Yeah.
I didn't know that it did that. Great. Let's do that. Sepal X, because that doesn't exist in this data set. That's really annoying. I'm trying to generate an intentional error. Let's do this. Head of X. X doesn't exist. So knit. Great. Now it says error in head X, objects X not found. That was different than what I expected it to say, because usually it doesn't tell you what line of code that you actually messed up on. It'll tell you the title of the chunk and the number of the chunk, which is just helpful for navigating the document. Potentially it changed since the last time that this occurred for me. But in any case, it's useful to title your chunks. So let's change this back to plot Iris sepal length and Iris sepal width so that it keeps our title correct. Okay, so that's nice. We can title our chunks. But the other thing that we can do is control the behavior of these chunks as well. So let's say, for instance, that I want a table of Iris, the head of Iris, those first 6 lines, but I don't actually want to see the code. So in this case, I would do echo equals false. So that's a comma after the title, and then I put the parameter echo equals false. And you can type it as F or the full word false in all caps. And now if I click knit on this, it will run. And you no longer see the code associated with that code chunk. You only see the output. Let's say that I want to do this across all of the code chunks. That's when I can come up here and start changing the default behavior. So instead of echo equals true, here I can put echo equals false. And now throughout the entire document for all of my code chunks, I will not see any of the code. So if I knit this, Now all of the code is gone and I only see the output of that code. The other two most common ones that I use are include equals false and eval equals either true or false. So include designates whether you want the output of the code to be included in your document. So include says, yes, I want the plot that you just generated to be printed. Like, yes, the code generates it, but I also want it to be in the document. And then eval means yes, please evaluate this code chunk. If you put eval equals false, the code chunk will not be evaluated at all. So let's test that down here. If we do echo equals true and eval equals false, we will see this code, but we will not see the output of this code because it's not actually being run. It's not being evaluated. Great, and I have some weird parameters up here where I said include equals false for everything, so nothing was shown. So let's do include equals true up top. And then this one is shown. It does not tell us the code chunk, but here we put echo equals true and include equals false. So we see the code, but it's not actually evaluated, so we don't see the output. Questions about that?
So include means that if you put include equals false, it does not run the code chunk.
Sorry, include equals false runs the code chunk, but does not include the output.
So it doesn't display the output.
Correct.
Okay.
Eval equals false, it does not run the code. Yeah. So eval equals false is really useful if you want to tell someone like, I ran this really big bash pipeline, it takes 12 hours, but look at my code, isn't it pretty? But you don't actually want to rerun it. So eval equals false is good for that. Include equals false is like, I ran head on this object 6 times and I don't want you to see that. It was just for my debugging purposes, but I'm being lazy and not going through and erasing it all. So include equals false for that. Don't show me the head of that data object after every operation. Yes, Hannah?
Okay, sorry. So include runs it and doesn't show the output, but then
Correct.
echo hides the code.
Echo hides the code.
But does show the,
But
like doesn't.
yeah, why don't we write this down? Okay, so echo controls whether you see the code chunk. Echo equals false. Don't show the code chunk. Echo equals true. Show the code chunk. Include controls whether you see the output of the code chunk. So include equals false. Don't show the output. Include equals true. Show the output. And then the last one that I really like is eval controls whether the code chunk is evaluated, run. Eval equals false. Don't run the code. Eval equals true. Run the code. So if you generate an object in a code chunk, like let's say iris head is equal to the head of iris, and you put eval equals false, and then in a later code chunk, sorry, but echo equals true. In a later code chunk, you say eval equals true, echo equals true, and you want to print, see the object iris head, and then you click knit, error in object iris head not found. because it did not evaluate this code chunk. So now it can't use this object because even though you typed out the command to generate it, it's not being run, so it can't use that. So we'd have to have that one as eval equals true. Okay. One other nifty thing, or I guess two, is fig height. And then fig width. So if we change these each to 4 by 4, and then let me just do a quick check, echo equals false. Let's do eval equals true because we want to actually see that. And include is equal to true, and echo is equal to true. Great. So I was checking to make sure that we could actually evaluate and include the figure that was generated in this second code chunk here where we plot iris sepal length by iris sepal width. And what should happen is that now our figure height and width should be 4 by 4, so it should change it to a square instead of a rectangle. So if I knit this, that's a different size than it was before. So we've globally controlled the size of this figure. You can also do that within the individual code chunk header to change the size or dimensions of your output figure. Okay. Right, and there's actually two more that are really helpful. So message equals false and warning equals false. So let's test this one. Let's leave message equals false as, or let's change message equals false to message equals true. So I'm going to put a code chunk in where I'm loading a library, and I'm going to do library dplyr. If I run this in my own session, we see that dplyr is quite verbose when you load it. It tells us that it attached the package, and there's some things that are masked from package stats and some things that are masked from package base. That's good. We want to know that, but if we're generating a pretty report, you don't necessarily want those things put into that report. So if we have message equals true up here, if we knit this, we get those dplyr messages at the top of our document. So then if I change this to message equals false, and then I knit it again, those messages are now gone. So it helps with the formatting. Same thing with warning. If you have any code that generates a warning, oftentimes if you've been running this code, you know why the warning's there, and theoretically you should be okay with that warning and not worried about it. Like one, for example, is if you're running DESeq and you used tidyverse to read in your samples file, well, those samples are not going to be factors, and DESeq is going to coerce it into a factor when it runs it, and it's going to warn you that it changed your data into a factor, and if you weren't okay with that behavior, you should stop and check it. Usually I'm fine with it turning it into a factor because that's exactly what I want it to do, but I don't want to write the lines of code to change it to a factor before I do it because I know what behavior it's going to do, so I just want to suppress that warning message because I don't really want to see it, and I'm totally fine with that behavior. Okay, questions about global options. So global options set the automatic things for each code chunk, sorry, for all the code chunks. And then if you want to change the behavior in an individual code chunk, that's what these things do. So these override the global options that you have. Okay. Yes.
Can I make comments in the code chunks?
Absolutely. And then they show up. I usually write a bunch of code in my code chunks because if I'm producing this, it's either to document what I did for myself or for somebody else. And sometimes I want like just my results to be talked about in the actual text that I'm writing. And so then I comment my code very heavily within the code chunks.
Those ones always have they're different than outside of the
Yeah.
code chunk.
Yep. They always have to have the comment in front of the hashtag in front of them if they're inside of a code chunk. Okay. There is one part of the YAML header that we did not cover yet that I want to include, that I need to find so I get the syntax right. You can make it so that the figures that are output by your R Markdown are saved as individual files as well. So if you do fig.path equals to, and then I'm going to do figs with a little slash after it. I'm going to put that on a new line also. What that'll do is create the directory figs in the same directory that my R Markdown file lives in. You have to have the slash after it though, because the other thing that you can do, well, I'll show you in a second. If I have the slash and I knit this, it generates this fig directory, which is already generated when you click knit anyway. It's just usually deleted as a temporary file. And now my plot iris1, which it borrowed from the name of my header, plot iris, and put a -1 after it, is a PNG within that folder. If I add anything that doesn't have a slash directly after it, like cool analysis, and then I knit this, I now have something called, within my figs folder, cool_analysis_plot iris1. So it appended that cool analysis as well as the figs directory, which is what I have written here. So it gave me the whole thing as the prefix to the file name. So you want to end with this slash, and then it'll put them inside of that folder for you. Questions about that? Okay. Yes. No, that wasn't a question.
It's not a fully developed question.
Okay.
Big words.
Then the last really cool thing about R Markdown that I actually just learned recently is that you can do R computation inline as well. So let's say that you've calculated the mean for something and you want it to come up over and over again. So you can say something like the mean of the iris steeple width is, and then you do one backtick. You type R because that's the engine you're running this in, and then a space, and then your code. So for us, it would be mean of iris $ steeple, I think it's a capital W, yes, steeple width. And then you close it with your backtick, and then you keep typing. There's a typo, I'm gonna ignore it. And then when you click knit, when your document pops up, if we go to the bottom, the mean of iris steeple width is 3.0576333. Isn't that cool? So it put that number in the proper formatting for you. Usually we don't want that many numbers, so I would give the round function, and I forget the arguments to round, so I'm going to do a question mark round in my console and scroll down, and then I want to give it digits equals 2. And if I knit this, I now see that the mean is 3.06. So if your data changes at all, you don't have to go back through and edit these numbers in the text. They'll be auto-edited for you, which is really, really, really nice. Okay, questions about that? The last thing I want to say is, without really showing any examples, is that R Markdown, especially when you're knitting to, there are actually two things I want to show. When you're knitting to HTML, you can use HTML code directly in your document as well. So if you see anything fancy on the internet, like some people have collapsing code chunks and that sort of thing, you can copy and paste that directly into your document, and that will work. It's really annoying to code in HTML, but you can do it if you find something that you particularly want. Although a lot of times the thing that you want has probably already been implemented in a package by somebody else, so you should maybe Google for that first if you don't want to deal with HTML. I'm going to fix this typo because now it's bugging me. Okay, the last thing that I want to show, I'm going to install a package called Cable. I actually already have it, so if you don't have it, go ahead and install it by typing install.packages and then in quotes, Cable, spelled K-A-B-L-E. And then I'm going to generate a code chunk. I'm going to call it Cable Iris. And this one I'm going to type library, Cable. And then instead of head of iris, I'm going to type cable, head of iris. And I want to make sure that this is include is equal to true. And now if I knit this, there's an error in line 15. Did I spell cable wrong? I thought I had it. Unless it's actually just called cable extra, which
I
is,
think it might be in
so is it already loaded?
no, I think you would have to look back.
I think you're right. Okay, so we do that with knitter instead. Sorry, I'm checking to see if this works. Yes, it worked. Okay, so install knitter instead if you don't already have it, which I think you do have it if you have R Markdown installed, but you would do that with install packages knitter. And then you can use the cable function. And when you click knit, what happens is it will pretty format your table for you. So instead of this head looking like this, we get it to look like this. And there's all sorts of formatting that you can do associated with using cable. It changes based on whether you're knitting to a PDF, a Word document, or an HTML, what your options are, but just the defaults even look a lot better than using head and that sort of thing. Okay, I think that's actually all that I wanted to say. Any questions or any R Markdown goodies that you've heard lore about that you would like questions answered about?
How did you get on like bash as an option for your code?
Sure. Yeah, so when you click insert, yours doesn't have bash as an option. Is that what you're saying? So I think these, that's because you're on a Windows. So what we would have, it's fine, we can fix it. So what is happening is when you downloaded R in RStudio, it's automatically using like the system default. And then it looks around it to see what other system defaults exist. So on my system, I have Stan, SQL, RCPP, Python, D3, and Bash in my path. So like R just can look for them and know where they are. Sometimes what I do is install like R and RStudio and all of those sorts of things inside of a Conda environment, launch them from that Conda environment, and then it will look for these paths around that Conda environment. So we can figure out how to do that on your Ubuntu subs shell, probably. If it's an option, we can figure it out. But yeah, so it looks for the things that are already in the path that like it default looks to. And those are probably just not in your path. Other questions?
So let's say you were to have an R Markdown. You're basically going to have to rerun this most likely in the future on a different data set, exact same R Markdown. I assume you're going to want to assign a variable. You know how to do that? Like to upload instead of like the very first file that you load, to load one file and then have it like to assign a name and then the like the first part, sorry, I feel like start. If so you upload this new file, let's say the file is called petals, and so you say, I want my variable name petals, so your outputs have petals at the beginning, say petals at the beginning, but going all the way down.
Yes. So that's like the fig path thing, I'm pretty sure, where you would change the, like, so in this case, we would put it as iris because all of these are iris outputs. So I don't know what the one is for. I press tab and now I see all the options. I wonder if it's just path. Ooh. No, I'll have to figure it out. But I'm sure it's a similar solution to something like this. So you're saying like anything that you write out, append a path to it. Yeah, we'll figure out the solution, or prepend, not append. We'll figure out the solution to that, but it's going to be something like this. Yeah. Any other questions? Cool. Well, thank you for coming. I hope you learned a little bit about R Markdown.